bluish area of the histogram and also a big cluster of pixels around the blackish area of the histogram. And that would be a kind of descriptor, and maybe also a bit for, sort of skin color or something like that. That would be a descriptor of that person that's a little bit unique. And we do this not just for the frame that we've detected, but actually we do it over all the frames that we've detected in this trajectory. So, because we're assuming that we're looking at the same person or group of people over the entire trajectory. So we accumulate all the evidence from all of those frames. Okay, so that might give us, up to sort of 20,000 pixels if you're looking at sort of 30 or 40 frames times a, a few hundred pixels or something like that in each of the segments. And so it can build us quite a reasonable descriptor. Well, okay, so we have a descriptor now, H1 for target number 1, and a descriptor for, this target number 5 or whatever. We want to know, well, how well does this descriptor match that descriptor down there? Okay, so now, that means we now need a way of matching colors, or color histograms. And so we're going to use something called the Bhattacharya distance in order to do that. So the first thing we have to do in order to do that is we have to normalize our histogram. So originally we had all the individual counts, but we want to normalize it so that all of the counts are, rather than individual counts, they're sort of floating point numbers, and all of the numbers in the array, this three-dimensional array, will add up to be equaling 1. So we just take the original array and divide by the sum of all those numbers. Okay, so that's for the first matrix, and we do that for all of our matrices. That gives us our sort of normalized descriptor of the matrix. And then we can use the Bhattacharya distance, and that's defined by this formula right here. So if two matrices are equal, then that means for each red, green, and blue cell in that matrix, they're going to have exactly the same values, and we can sort of multiply them together. If we multiply them together and they're equal, then they're going to be, the square of the thing. We take the square root, and we've added it all up. Okay, that again is going to equal to 1, because that's what we've done for the normalization. And that will give us a distance of 0. So that's good. If the two matrices are identical, the two descriptions are identical, we get a Bhattacharya distance of 0. And similarly, if the matrices are very unlike each other, we might, at the worst case, we might get a distance of 1. So the bigger the distance, the less similar those two matrices are. We're going to make the assumption that there's a little bit of noise, and so therefore, if this distance is small, it's still likely to be the same target. Now we have a little practical consideration to deal with